Hello, everyone. Today we are going to uh, learn how to solve a problem of soil permeability in a stratified soil, which means that the soil is a layered soil, which means that there are different type of soil that we layer. Okay, or because in most of the real situation or most of the field cases, the soil has different type of layers within the soil. So you have clay, and you have rock, and then you have sand, and you can have clay, or you can have clay and sand. So you'll see different layers of soil in the actual field. So one of the problem that we are trying to address today is how do we calculate the permeability, or even how to solve the problem arises from this stratified soil with respect to the soil permeability. So the first thing is we have to learn is the because we are going to use the equation Q, which you have learned in your soil permeability concepts, that Q, which is your flow rate, is equal to the coefficient of permeability, or permeability coefficient, or hydraulic conductivity is flow rate is equal to K, permeability coefficient, into I, which is your hydraulic gradient, and A, which is your cross-sectional area. And please remember that the area is always perpendicular to the flow. And here, this is mostly solved in a 1D problem, which means that the direction of flow is in uh, one direction. So your K, if it is a stratified soil, like if you have a layer of soil, you have soil A, B, and C. Now we have a problem for this because each soil has its own Ka, Kb, and Kc. So how do we use this problem to calculate the flow rate, or even to calculate the conductivity of the soil? So there comes a term we call as solving the equivalent. So we need to find what is the equivalent conductivity for this stratified soil. So for that, we need to look at the direction of the flow. If the direction of the flow is parallel to the layer of soil, then we will have to calculate what is called as KH equivalent, which means that it's a horizontal flow. And you can also think it in this term, in this way, that if your flow reaches all the layer of the soil at the same time, then that is your horizontal flow. And what is vertical flow then? Vertical flow, if this is your soil layer, and if your flow is perpendicular to the layer, then we call it your vertical flow. And your K equivalent in this term will be KV equivalent. And so if you get confused again, like how do I know whether the flow is perpendicular to the layer? Just think it in this way, that if you have if the water has to flow a layer one at a time. For example, in this case, you'll see that the flow will reach soil A, and then after reaching soil A, it'll reach soil B, and then after reaching soil B, it will reach soil C. So that means it has to reach one at a time. So that is, your flow is perpendicular to the layer, and so that will be your vertical flow. But if the flow reaches all at the same time, in this case A, B, and C, the flow reach all at the same time, and uh, so that means that your flow is parallel to the layer. So that will be your horizontal flow. But doesn't mean that when I say reach at the same time, doesn't mean that the permeability are all the same. No, I'm just saying that it reached this point, the starting point, at the same time. So you know that the flow is uh, parallel. And for the vertical, the flow has reached one at a time. So in this problem, you'll see that it say that the figure show three layers of soil. You have here soil A, soil B, and soil C. And it says that the water is supplied to maintain a constant. Um, the soil has a cross-sectional area, and the flow is perpendicular to the area. So this is the area, and it's given to us, which is 200 millimeter by 200 millimeter. So the area is given to us, and it says that the water is supplied to maintain a constant head difference, and that is not known to us, which is h. And the rate of flow is given to us, which is 500 centimeter cube per hour. And the hydraulic conductivity of the soil is already given to us, kb and kc. Okay, so the question here it asks, it says that if your q has to maintain 500 centimeter cube per hour, we can convert this into 0.139 centimeter cube per second, because we'll be working um, with centimeter per second. They say that if this q has to be maintained, what is the head difference h that it should be maintained? So to solve this, you can think is in this way. Let's say that if you put a pressure tube or pressure gauge, you will see that the H, we have learned from Bernoulli's equation that the energy at 1, total head at 1, is also equal to total head, this you say here as 2. You'll find that H1, which is your total head, will be equal to H2 using Bernoulli equation. What does that mean? It means that if you put a pressure head here, or sorry, if you put a pressure pipe here, or pressure gauge in at point 2, you'll see that the water will flow up till this level. So the question is, and then also you will do the same thing if you put another pressure pipe here, a pressure gauge here. You will see that the um, the energy here, which is your energy, let's say this is 3 4, this is 3. You'll see that according to Bernoulli principle, h3 will be equal to h4. So which means that your water, if you put a pressure gauge here, your water will flow till this level. And now the question is, if the water flow from this point, the starting of your soil, till the end of the soil, what is the head difference? And we take this as your datum. So we know that there is a flow. So when there is a flow, the energy also there will be energy loss, or your head difference or head loss. So the question is, if there is a flow and the flow has to maintain a flow rate of 500 centimeter cube per hour, then what will be the head difference in order for the q to be maintained at 500? So the question is, we have to use q is equal to k I a. But k, because this is a stratified soil, so we need to know um, what k are we using, because we have to find an equivalent permeability coefficient or equivalent k. So let's look at how the flow of the water is uh, flowing through the layer of soil. So you see that the flow has to pass through layer A, and then has to pass through layer B, and then has to pass through layer C. So because it has to pass one at a time, so we learn also, if you compare, that the flow has to pass one at a time. So our K in this case will be equal to KV equivalent. And KV equivalent, if you look at the formula for calculating KV equivalent, which means that the flow is, this is a vertical flow. So your KV equivalent is equal to H and HA KA plus HB KB plus HV KC, and H is the total height or total depth or total length. So in this case, we know that each soil has a length of 150 meter, so it'll be 150 millimeter plus 150 millimeter, and HA will be 150 millimeter divided by Ka. Ka is given to us, which is 10 minus 2 plus 150, and then 3 into 10 to the power minus 3 plus 150 in 10 into 4.9 10 to the power minus 4, and all this unit are centimeter per second. So you can see that the unit are just m millimeter will cancel out, so your final value will be centimeter seconds. So the final value that you get from here is 1.212 10 to the power minus 3 centimeter per second. Okay. So we know from this equation q equal to kia, we know q, we know k. I is what we need to find. I is equal to h, total head difference or head loss, divided by the length of the soil. In this case, we know that it'll be h, length of the soil is 150 plus 150 plus 150, and that will give you h of 450 millimeter. But we want to make sure that we are that our unit is consistent, so we are going to convert into centimeter. And then kia, so we know I also, it's h is what we don't know, and a is also known to us. A is given here, the cross sectional area, and the one that is perpendicular to the flow. So we already know that this is the cross sectional area and it is perpendicular to the flow is 200 by 200. So it'll be 200 millimeter by 200 millimeter. So I can put here as 20 centimeter by 20 centimeter, and this will give me 400 centimeter square. So now we know that Q is equal to K H over L A. So from here we can find that your Q is 0.139 equal to 1.212 10 to the power minus 3. H is what we don't know, L is 45 centimeter, and A is 400 centimeter square. So if we solve that equation, you'll get that H is equal to 12.90 centimeter. So this is the head difference that you should have in order to get the flow of 500 centimeter cube per hour flowing through the soil A, soil B, soil 3. So this H has to be equal to 12.90 centimeter. Okay, so that is the part A of this question. I will see you next for solving part B.